All right, let's jump right in. Today, we're laying out the essential blueprint for one of the most vital integrations in all of healthcare IT, connecting an electronic health record, or EHR, with a laboratory information system known as an LIS. This connection is the absolute foundation for timely, accurate clinical decisions, and there is zero room for error.
This quote really hits the nail on the head, doesn't it? It gets right to the core business problem. When lab data is scattered everywhere, patient care suffers. So as business analysts, our job is to be the architects of that bridge, a bridge that's not only seamless for clinicians, but is absolutely solid when it comes to data integrity and patient safety. So here's our game plan. We're going to walk through this as a 5-stage project. We'll start with the goal, then architect the data flow, map the HL7 message, design the clinician's view, and finally validate the whole thing for accuracy and safety. Okay, let's start with stage 1, the unified viewer goal. Before you even think about systems or data, you have to nail down the why. What is the business trying to achieve? And who are we building this for? Well, you've got a few key groups at the table, and they all have different priorities. Clinicians need speed and easy access, but then you have the QA, privacy, and consent teams. Their job is to be the guardians of accuracy, compliance, and patient rights. A successful project finds the perfect balance between all of these perspectives. And those interests, they translate directly into these core business requirements. We need that unified view, sure, but it has to be built on standards like HL7 or FHIR. It absolutely must guarantee accurate patient matching. That's a cornerstone of patient safety. It has to normalize data using codes like LOINC for consistency. And of course, it has to enforce privacy and consent rules without fail. Each one of these is non-negotiable. Now that we know what we need to build, we can move to stage 2 and figure out how. This is where we architect the data flow and create the technical blueprint. So think about the journey of a single lab result. It follows these 6 clear steps. It starts with an order, the lab system generates the result, and then it's sent out. Now, this middle step, validation and transformation, is where the real magic happens. This is where raw data gets cleaned up and standardized before it ever hits the EHR and shows up for the clinician. And to manage all this, we almost always use what's called a hub-and-spoke model. You have an integration engine that acts as the central hub. Just picture an air traffic controller for data. It takes in all the messages from all the different labs, it standardizes them, and then it routes one clean, consistent message to the EHR. This makes everything so much easier to manage, log, and scale later on. Now that hub is getting data from 2 main places, your own hospital's internal lab and external labs. And let me tell you, this is where a business analyst's attention is absolutely critical. That external data, it needs to be rigorously normalized. You have to make sure the patient IDs and the test codes are translated perfectly to match your internal standards. Get this wrong, and you've got a serious safety issue on your hands. Okay, time to roll up our sleeves. We're now at the technical heart of the project, mapping the HL7 message. This is all about turning raw, cryptic data fields into something that has real clinical meaning. The standard that makes this all possible is Health Level 7, or HL7. It's a universal language of healthcare data. Specifically, for lab results, we're using the ORU R01 message. You can think of it as the standardized digital envelope that carries the result. Our job is to build a system that can open that envelope and understand everything inside. Inside that envelope are different sections, called segments. And for our purposes, 4 of them are absolutely essential. You have the MSH, that's the message header, telling us who sent what and when. Then the PID, for patient identification. The OBR describes the test itself. And finally, the OBX contains the actual result. Together, they tell a complete story. This patient had this test, and here's the value. Now, this is where patient safety really lives or dies. Getting this field-level mapping right is everything. PID-3, the patient's medical record number, is the absolute foundation. If that's wrong, nothing else matters. OBR-4, the test code, needs to be mapped to a universal standard like LOINC, so you can compare a glucose test from Lab A to one from Lab B. OBX-5 is the actual value, and OBX-11 is the result status. It tells the clinician if the result is final, preliminary, or, critically, if it has been corrected. So all this detailed technical work brings us to stage 4. How do we take all these mapped fields and turn them into something a busy clinician can actually use? It's time to design their view. This is where it all comes together for the end user. A cryptic field like OBR-7
simply becomes a clean label, collection date/time. The values from OBX-5 and OBX-6 are combined to show the result and its units. This translation from technical code to human-readable information is the core function of a business analyst.
And you don't just guess at this, you document every single decision in a UI data dictionary. This thing is your project's source of truth. It traces every piece of information the clinician sees on screen, the test name, the status, the lab source, all the way back to its specific home in the HL7 message. This ensures total clarity and makes the system so much easier to maintain.
All right, we've reached the final, and you could argue the most critical stage of all, validation. We've designed and built the system, but now we have to prove, beyond a shadow of a doubt, that it delivers accurate, reliable, and safe results every single time. A huge part of successful validation is defining a very clear scope. We are testing the inbound message processing, the patient matching logic, and how the data looks in the EHR. What we're not testing are things like the lab's internal machines or what happens in a downstream analytics tool. This focus is key to getting the job done right. Our test cases have to target the biggest risks. For example, what happens if a message comes in without a patient ID? The system must reject it, period. That's a fundamental check for patient safety. We have to prove that consent rules are enforced to protect patient privacy, and we absolutely must confirm that a corrected result, marked with a C in OBX-11, replaces the old value and is flagged clearly. That guarantees clinical accuracy. So, before we flip the switch, we run through one last pre-flight check. Have the mappings been double-checked? Do the consent rules work? Are the audit logs capturing everything? Is the support team ready for day one? And, maybe most importantly, have the clinicians signed off on user acceptance testing? We don't go live until every single one of these boxes is checked. Which brings us to the final question. When you follow this blueprint, when you define the goal, architect the flow, map the data, design for the user, and validate everything, you build more than just an interface. You build a system that delivers safe, unified, and truly actionable information. The blueprint is here. The question is your system ready to deliver?